All right, penultimate lesson of the year. Penultimate, for those of you who don't know, means second to last. So this is our penultimate lesson of the year. It's an introduction to probability. And so, first question, suppose you're playing Monopoly with your friends. Hopefully you guys have played Monopoly before. And if you haven't played Monopoly before, the way that you get around the board is you roll a pair of dice. So you are coming up to the free parking space, which if you land on it, you would win the $500 pot. You really need that $500, and you are 6 spaces away from landing on free parking. You blow on the dice, you start chanting, come on, 6, come on, 6. So what's the probability you roll the dice, you get a total of 6, and therefore land on free parking and win the $500? So this is definitely a good math question. It's something that definitely, it absolutely comes up. My own children have been playing Monopoly during the pandemic, during the stay at home. And so can we put a number on rolling a 6? And yes, we can. So here's a little bit of probability kind of background. This is how I think of probability. When I do probability, I think of it as like a thermometer here. And this is our probability thermometer. And the highest that this thermometer can go is 1, and the lowest it could go is 0. 1 means it's guaranteed to happen. And this is never will occur. 0 would be never occurs. So, for example, the probability that Christmas is in December is 1. The probability that you will have a birthday on February 30th is 0, since there is no February 30th. So, and all the probabilities in between, the most important probability, in my opinion, is the probability right in the middle, which is 1/2. That's your typical coin flip, right? So the probability when you flip a coin of getting heads is 1/2. Probability of getting tails is 1/2. When a woman gives birth to a baby, the probability that it's male is 1/2. The probability that it's female is 1/2. If you were to pick a card out of a deck, the probability that it's a red card is 1/2. The probability that it's a black card is 1/2. And so you have probabilities all in between on this probability thermometer. So where is the probability of rolling a 6? Where is it? Is it in this section right here? Or is it in this section right down here? Is it something that happens more than half of the time? Or is it something that occurs less than half of the time? So we're going to figure that out. Before we do that, let's get a little vocabulary going for us. So the act of rolling a pair of dice is called a random experiment. And picking a card out of a deck would be a random experiment. Flipping your water bottle, when that used to be a fad, flipping water bottles is a random event. Going bowling, rolling a bowling ball down the alley is a random event. Hitting a baseball is a random event. You don't know. Yeah, there's no way of telling beforehand just how any one roll is going to come out. The way that each roll comes out is called an outcome. In our case, our outcome, we want a 6. And an event is the set of outcomes. So this rolling of a 6, there are many ways we can do that. The total on the 2 dice is 6. How many elements in it? Well, Just imagine, you roll the dice, and it totals up to be a 6. What could those dice look like? Well, you could have a 1 and a 5. That adds up to 6. How about a 5 and a 1? Since they are two separate dice. 2 and a 4. How about a 4 and a 2? And then 3 and a 3. Now, can't write 3 and 3 twice because if both dice are a 3, then the other way around is still that same exact event. So how many elements in this event here? Well, 1, 2, 3, 4, 5. There are 5 elements. And the last little bit of vocab is what we call a sample space. And that sample space is how many elements are there in rolling a pair of dice. So when you roll a pair of dice, how many possibilities are there? Well, I'll give you a little hint there. 6 times 6 is 36. And so to find the probability, you take this number right here, the 5, and that's the number of outcomes in the event. And 36 is the number of outcomes in the sample space. And so our probability, the probability of rolling a 6, is 5 out of 36. If you want to put that into a decimal, you most certainly can, but it's completely appropriate to answer as a fraction. As a decimal, this is about 0.14. It's so about 14%. All right, where did that 36 come from? Well, the 36 comes from this little diagram right here. And this diagram here is showing us all the different 36 outcomes of when you roll a pair of dice. So like this is a pair of 1s, all the way down to the bottom here, this is a pair of 6s. So each of these is an event. And there are 36 of them. If you count them all up, there will be 36 events. Rolling a 6, well, you can just kind of find those in here and, highlight them, I guess. And so here is one that is rolling a 6. Oh, that's not working out too well. Let's just do it in pen. Yeah, that's better. That's a 6. That's a 6. That's a 6. That's a 6, and that's a 6. And so there you go. You got your 5 out of 36. All right, folks. So use this diagram, and you can answer. Pause the video, and you can answer these questions down here on rolling dice. So here are your solutions. I notice I did not reduce any of those fractions. It's not necessary to reduce the fractions. If you want to, you can, but it's not necessary. Sometimes it might make sense to reduce a fraction. So like, for example, the probability of rolling a 5, letter B, right, is 4 out of 36. That reduces to 1/9. So sometimes it's easier to understand that it would happen 1 out of every 9 times, something like that. So, or you could even do it as a decimal, which would be 0.11, 11%, you could say. But you don't have to reduce your fractions. Okay. All right. Cards. There are 52 cards in a deck. Half of them are red, half of them are black. The red are 2 suits, hearts and diamonds, black, spades and clubs. They are not called clovers. That is a club. And so there you go. Try these out. The outcomes, there are 52 outcomes, so that will be your denominator. And you could use this diagram to help yourself out. So here you go. A lot of times it might make more sense to reduce. Like here, you don't even have to write 26 out of 52. You know half of the cards are red, so you could just say 1/2. You know that a club is one of the 4 suits, so you could just say 1 out of 4. An ace, you know that there are 13 cards in each suit, so 1 ace in each suit, 1 13th. Same thing with 7. So if you feel like you want to do that, you most certainly can. So there you go. Just so a definition, face card means you have a human face on the card. Aces do not have a human face. These are the cards right here that have human faces on them, and there are 12 of them. So your exit slip will be some probability using coins. Should be decent, and we will see you next class.